Right, in this video, we are going to be going over the 7.1 content check, which was over graphing logarithmic functions. If I were you, I would have my notes out and open to 7.1 because I might show graphing logarithmic functions in a way different than your teacher showed. But either way, it's good to learn a couple of different ways to graph these and to have the parent functions sitting in front of you from your 7.1 notes. So the first thing I want to do when I look at these log functions is identify what the log base is and where the transformations are going to move the graph. So when I look at the equation in problem 1, I notice that I'm graphing log base 2 of x, and it has 2 transformations. The minus 3 grouped with the x is going to move our entire function to the right 3, and the plus 1 is going to move the graph up 1. So when I move with those transformations, I'm going to take the entire y-axis and move it to the right 3, which is then going to become the new vertical asymptote. And so I can go ahead and just make that my dotted line. And up 1 means I'm going to take the entire x-axis and move it up 1 space. That is not an asymptote, but it is going to help you get your starting point when you graph the log base 2 of x function. Okay, so again, looking at this log base 2 of x, I'm going to graph that now on my new x and y axis, essentially. I always know that with these log functions, I'm going to have a point at at 1, 0. So looking at my new 0, 0, my new origin, I'm going to go to the right 1 space and put a point. Okay, then again, this is where I might do things differently from your teacher, so it'd be helpful to have your notes out. What I tell my students is we always look at our base number, and every time we move up on the asymptote, we go out by a multiple of that number. So if I go up 1 space on the asymptote, I'm going to go out 2 spaces. Then I'm going to travel back to the asymptote again, go up 1 more time, and this time I'll go out 4 spaces. 1, 2, 3, 4. If I had room, I could go over to the asymptote, up again, and this time out 8 spaces, but I don't have room to do that on this graph. So I can fit these nice 3 points on the graph. I'll curve it so that it's approaching the asymptote going down and leaving the asymptote going up. If you wanted to at this point, you could erase the new x-axis that you have drawn. It's not actually part of your graph. It just helps you, again, get this first starting point. You can erase it. You can leave it. I don't think it matters a ton to your teachers, but ask if it does. Okay. All right. Now when I look at domain and range, domain, remember, is the x values of the graph from left to right. Range is your y values of the graph from bottom to top. So when I look at this graph for the domain, I notice that it's getting stopped by the asymptote at 3. 3 is the smallest x value your graph is trying to get to, but it's never actually going to touch it. So we're going to put a soft bracket there. And then it goes forever to the right to infinity. The range on log functions is unrestricted. It's going forever down and forever up. So range, we're going to say, is negative infinity to positive infinity. All right, moving right along to the next one. Again, the first thing I want to do is identify the log base. So in this case, it's a log base 3 of x that we're graphing. With this one transformation, that minus 2 says we are moving the graph to the right 2. We are not moving up and down, so the x-axis is going to stay in place, but I'm going to take this entire y-axis, move it to the right 2, and go ahead and draw in the new asymptote to the right 2 spaces. Then again, I look at my log base. I know it's a log base 3. So again, I start by putting a point 1 space to the right on the x-axis from the asymptote. And this time, every time I move up 1 space on the asymptote, I'm going to go out by a multiple of 3. So if I go up 1 space, I'm going to go out 3 spaces now. If I go up again on the asymptote, I would be counting out 9 spaces. Let's see if I have enough room to do that. 1, 2, 3, 4, 5, 6, 7, 8. It would be over here at the 9th space. We ran out of room. If you wanted to put it there, you could. If not, no big deal. But again, you're going to kind of make it go down, make it look like it's approaching the asymptote, and then it's going to go out forever. All right. So my last 2 questions on here are my limit questions. This first one is asking for the limit as x is approaching infinity. That's asking me to look at the right side of my graph. As my graph is going forever right, I'm focusing on this arrow. That arrow is going forever right, but it's also going up forever, saying that the function itself is approaching positive infinity. The next one is asking me to look at x approaching 2 from the right. So that means my eyes need to start on the right side of my graph and follow the curve to the asymptote at 2. So if I start on the right side and follow the curve to the asymptote at 2, I notice that my graph starts going down forever, meaning that that limit is approaching negative infinity.